Hello everyone, welcome to Civil Learning Online. And today in this video, I will be discussing about three-moment equation. This is one of the method to analyze the indeterminate structure other than slope deflection method, moment distribution method and kani's rotation method. This is going to be a little bit different. So without any further delay, let's get started. Here in this question I will be using the three moment equation to find the moment at int A, B, C and the moment at int D will be 0 as it is hinge support. And before beginning the solution, let us first check out some cases of three moment equation. So here is the general equation of three moment equation, that is MA times L1 by E1 I1 plus 2MB times L1 by E2 E1 I1 plus L2 by E2 I2 plus MC times L2 by E2 I2 equals to minus 6A1 X1 bar by E1 I1 times L1 minus 6A2 X2 bar by E2 I2 times L2 minus 6 delta 1 by L1 minus 6 delta 2 by L2. Here EI represents the flexural rigidity while A1 represents the area of the cross section and area is actually the area of bending moment diagram, and X bar is the CG of that diagram, and here L represents the span. And the first case is when our EI is constant, means our flexural rigidity is constant, then what we need to do is we have to simply cancel out EI from the general equation. Then our equation comes out to be here, as you can see here, and here delta represents that settlement of the support. Delta represents the settlement, so it will be the case. And again if our EI is constant and there is no settlement, then we will have the equation of three moment equation as MAL1 plus 2MB times L1 plus L2 plus MC times L2 equals to minus 6A1 X1 bar by L1 minus 6A2 X2 bar by L2. Here settlement is 0, so this gets cancelled out, or its value is 0, so it does not comes here during no settlement. And EI is constant, so we do not need to take EI in this step in case 2. So now let's move toward the solution of the numerical. So guys, here is one thing that one should know while solving the numerical based upon the three moment equation, and we are provided with the fixed end or fixed support at one end. Here in the given question we have EI equals to constant and there is no settlement at the support. Okay, and we need to find the moment at A, B, C and the moment at D is 0. So whenever we are provided with the fixed support in any continuous beam, then in order to solve the numerical based upon the three moment equation, we need to take the 0 span left or right of that fixed support. As we are provided with the fixed support at end A, so we need to consider a 0 span A dash at span L naught from A, which will be left of the support A. If we were provided with the fixed support at D here, at support D, if it were fixed support, then we need to take a 0 span right of D, that will be D dash, and span will be L naught. Okay, I hope you guys understood this step. So our first step is going to be step 1, taking 0 span on the left of support A. Then we need to draw a diagram here first, then our solution will begin. So I have drawn a 0 span left of A, that is A dash. Now let us consider span A dash A and AB. Before that, we need to find the area, moment area and CG of span A dash A. So step 2, let's write it down here. Step 2, consider span A dash A. Always remember that for zero span we have moment equals to 0 as well as L naught is 0 and the area A naught will be 0 as well as CG of this zero span will be 0. Now let's move toward span AB. So consider span AB, and considering span AB we will have moment equals to WAB upon L. So we will have here W is 80 into 2 times 3 by L, and L is going to be 5 meter. On doing so we will have the value of M1. This is going to be our M1. So M1 will be 96 kilo Newton meter. Now let us draw the diagram of this moment. See here guys, how to draw the diagram. This is our 96 kilonewton meter and the base is 5 meter. So let us find the area of this triangle, and the area will be given by A1 equals to half into base into height. So half into 5 into 96, we will have the value of A1 as 240 meter square. Now let us find the CG of this span. So CG of span AB, this is our end A and this is B. CG of span AB, taking A as origin, we will have here L1 plus A by 3, and the L1 is 5 meter, so 5 plus, and this span is 2 meter. You can see in the diagram here, this is 2 and this is 3, so this is 2 meter and this is 3 meter. So if we take A as origin, so our small a will be 2 by 7, oh sorry, this is 3 here. So on calculating the value, we will have here, this is going to be 2.33. Similarly, CG of same span AB, taking B as origin. Now we need to take B as origin. If we take B as origin, then its CG will be whole span minus this value, 5 minus 2.33. Then it will be equals to 2.67 meter. Now let's move. Now let's. It was for span AB. Same step we will perform for span BC. So let's write it down here. For span BC, so Here is a diagram. For span BC, we have the point load acting at away from the CG of this span BC. So we will again find the moment here, and for finding the moment we will write here M2 equals to WAB upon L, and the loading is 50 kilonewton. So 50 into AB is 4, A is 4 and B is 3 meter. So 4 into 3 by span is 7 meter. On solving, we will have the value of moment as 85.71 kilonewton meter. After finding the moment, we need to draw the moment diagram, bending moment diagram. After drawing this diagram, after calculating moment, we need to draw this diagram, and after this diagram, let us find the area of this diagram. So we will have here A2 equals to half into base is 7 meter into height is 85.71. so we will have the value of area as 299.98 meter square. Now let us take CG from B and CG from C of span BC. So CG of span BC from B, again the step will be same. Here the span is L2, so L2 plus A, because we are taking the CG from B, so A by 3, which will be 7, plus A will be 4 by 3, and on doing so, that is 7 plus 4 by 3, we will get here 3.67 meter. Now time to take CG of span BC from C. So CG of span BC from C, what we need to do is we have to subtract this value from 7 meter. So 7 minus 3.67 meter. On doing so, we will have 3.33 meter. Now time for span CD. Let's write it down. For span CD, so as you can see here, we have UDL in case of unloading on the span CD. So we will find the moment here as M3 equals to WL square by 8. So and the loading is 10 kilonewton per meter. So 10 into span is 8 meter, 8 square upon 8. We will have here value as 80 kilonewton meter. After this, let us draw the diagram, bending moment diagram of span CD, which will be a parabola due to UDL, and the area of this portion will be given by A3 equals to 2 by 3 times base into height. On solving this, we will get its value as 426.67 meter square. Now, and the CG of this span CD will be half of 8 meters, so it will be 4 meter. Now let us apply 3 moment equation for span A dash A and AB. So applying 3 moment equation in span A dash A and AB, we will be using the formula that was for EI constant and non-settlement, that is support does not settle. So we will have here M naught times L naught plus 2 M1 times L naught plus L1 plus M2 times L1 equals to minus 6 A naught X naught bar by L naught minus 6 A1 X naught bar X1 bar by L1. So now put down the value, as the moment for the 0 span is 0, so this is going to be 0 plus 2 times this is will be our moment at end A, and this is our moment at end B. so it will be written as MA because we need to find this value, and we had calculated M1, that was for the diagram of bending moment diagram to calculate the area, and we need to find this value, and the L naught is 0, and the L1 we have the span of L1 as 5 meter plus moment at B MB times L1 is 5 meter minus equals to minus 6 times A naught is 0, so this whole will be 0 minus 6 times A1, and the A1 is, we have the value of A1 as 240 meter square. And now how we have 2 CG for span AB. Now see here guys, we are taking A dash A, so CG will be for span A, for this A dash A we need to take CG from this side, and for AB we need to take CG from this side taking B as origin. We have calculated the value of CG of span AB taking B as origin, so we need to take this value, which is 2.67 divided by 5. Watch the video till end so that you will not face any kind of confusion, because same step I will be repeating in after this, and you will more clear that which CG we need to take and why. So on solving this, we will have a equation that is 10 MA plus 5 MB equals to minus 768.96. This will be our equation 1. Similarly, now we will be considering span AB and CD. So for span AB and CD, let us write down the equation and then we will put down the value. So its equation is going to be MA times L1 plus 2 MB times L1 plus L2 plus MC times L2 equals to minus 6 A1 x1 by L1 minus 6 A2 x2 by L2. So now put down the value here. So the value of L1 is 5 meters, so we will have here MA times 5 plus 2 MB times L1 plus L2 is going to be 5 plus 7, that is 12, plus MC times L2 is 7 equals to minus 6 into A1 is 240 into, now what to take as CG here. Now see here guys, we are taking span AB and BC, so for span AB we need to take CG taking A as origin, and for span BC we need to take CG from C or taking C as origin. Understanding or not? For span A dash A and AB we take CG from this side and from B as origin. Again for span AB and BC we need to take CG from end A and taking C as origin. So on doing so we need to put down the value here, 2.33 divided by 5 minus 6 into, and the value of A2 is 300 into 3.33 divided by L2. L2 is 7 meter. So on solving this we will have a equation 2. I am extremely sorry for this. This is span AB and here it is going to be span AB and BC. Now we need to take for span BC and CD. We need to move serially taking A dash A and AB, again AB and BC, then BC and CD. So our equation will be MB times L2 plus 2MC times L2 plus L3 plus MD times L3 equals to minus 6 A2 x2 by L2 minus 6 A3 x3 by L3. Now put down the value here, then we will have here 7 MB plus L1 plus L2, we will have here 30 MC plus, see here guys, our int D was hinge support. You can see in the diagram, let me show you. As you can see here, int D is hinge support, so its moment will be 0, MD will be 0, so we need to write it as 0 equals to minus 6 into 300 into, now see here guys, for span BC, now this time for span BC and CD we need to take B as origin for CG, and for D we need to take CG from taking D as origin. So x2 will be equals to 3.67 divided by L2 is 7 minus 6 into A3, and the value of A3 is 426.6 into CG will be 4 divided by L3, and the value of L3 is 8. Now we will get a equation here. Now we will get this as equation 3. We need to solve equation 1, 2 and 3. Now I am going to show you with how to solve this equation using calculator. So go to mode 5 for equation and again 2, select 2 and then now enter the value. This is 10 MA, so enter 10 equals to, and MB is a coefficient of MB is 5, so enter 5. Here MC is absent, so we will enter it as 0, and the value of D is going to be minus 768.96. press equals to, again 5 equals to 24 equals to 7 equals to minus 1527.32 equals to, now here MA is absent, so we will put the value of MA as 0 equals to MB, coefficient of MB is 7, so 7 equals to 30 equals to, and minus 2223.72. now after entering the value, press equals to, then the first value which we get will be the value of MA, and MA will be equals to minus 61.19 kilonewton meter. Again press equals to, then we will get the second value, that is MB will be equals to minus 31.4 kilonewton meter. Again press equals to, then the third value which we will get is MC equals to minus 66.79 kilonewton meter. After getting this value, we need to draw the final step, that is bending moment diagram. So let us draw the bending moment diagram of this equation or this problem. So this is our bending moment diagram. I hope this video was helpful to all of you guys. Do like, share and comment on this video, and thanks for watching this video. Have a nice day. I will be adding one more video, so stay updated by subscribing this channel. Thanks again. Have a nice day.